So yes, hello all. I'm Sergey, I'm CTO of ABTesty, and I'm here with Hervé, our lead database engineer. And we are here in order to explain to you how ABTesty scales the business with a lot of data, and what a semantic layer means for us today. So quickly, just to explain what is ABTesty, what we do today. So ABTesty is a client optimization platform. So first of all, we help our clients to analyze the traffic and the pain points in the different parts of the journey of the visitor. After it, our clients will do the experimentation. So it could be A/B tests, multivariate tests, multi-page, and many others. The test will be in place live from 15 days to 2 months normally. And after it, the client will decide if we need to push the patch or personalizations for the good audience, for the good segment of the visitors. So we work on the client side as well as on the server side and mobiles for our clients. What is our data changes today? So we collect a lot of data. In average, it's 20,000 records per second, and it represents 4 terabytes of data received and 8 terabytes of data stored per day. So the latency really matters for us. As well as for the reporting part, so our clients want to see the numbers in seconds in real time. But also on the segmentation part, so when we need to target the right segment of the visitors, and if it's prediction, so we should be fast, and sometimes nanoseconds matters also. We generate around 200,000 reports per day with a different complex of the queries. And sometimes the clients could keep live the campaign for more than 1 year, so we need to analyze more than 10 terabytes of data per query. Just quickly, the history of our data processing pipeline. So when I joined the company in 2015, it was kind of the synchronous ingestion part, so worked with the PHP workers and delivered directly into MySQL. So it works for this period because we don't have a lot of clients, a lot of data, a lot of traffic, but in a couple of months after I joined the company, we started to get the big clients and more of it. And so, yeah, we should move forward with something more reliable. And we choose GCP. GCP because Google Analytics, Google does kind of the same things that we need to do. So we chose it with the classic pipeline, with the PubSub, Dataflow, and BigQuery as the main bricks. So we work still in this architecture, more complex than in 2017, but still on the Google and still with the PubSub, Dataflow, and BigQuery and ClickHouse on the other hand. So we started to think for the first version of our semantic layer, so what we called Query Builder in 2019. It was here in order to translate the client's logic, the API logic, into the SQL queries. And in 2023, so we understand that BigQuery is a good choice, it's a good technology, but it's expensive, really expensive thing. So this time we chose ClickHouse to do the proof of concept with Hervé. So Hervé joined the company, I think in 2023, yes, for this. And yeah, we built it. Now we are migrating our clients into a new architecture and with the Query Builder version 2 that Hervé will explain to you right now more deeply in technicals.
Thank you, Sergey. Hi, everyone. Very happy to be here to share what we've done at ABTesty. So quickly, very simplified view of our data platform, at least the part that powers user-facing analytics. So we collect billions of users events every day. It goes through PubSub. We process the data in real time through Cloud Dataflow. And then we store the results into a new data warehouse, ClickHouse. And on the right side, on the serving part, we have many services, including the reporting and the self-service BI tool that we have on the platform. And what makes the bridge between the data warehouse and the serving is the semantic layer. So let's dive into it. Semantic layer, the concept is already a few decades old. I think the start was SAP early in the 90s. So you can find many definitions online, many different opinions on what it is. One that I specifically like is it's a business-friendly data model that ensures that everyone speaks the same data language. That means across tools and also across teams. So what it does in practice, it can do many things. For me, the 3 main points is it translates business logic into SQL. So when you have a report that require dimensions and metrics, from there you can generate very complex SQL. It accelerates insights by reducing the need on engineering for every single report that your marketing team could want. And then it ensures consistency by keeping the definitions of how you compute things uniform across all your tools. So for us, at ABTST, we built the semantic layer in-house, as Sergey said. We started many years ago, and we did a new version this year. There were a few design goals. So first, it needs to integrate easily with our analytics stack. Second, we needed dynamic goal definitions, because our clients, when they create experiments, they will define success metrics for their experiments. And each experiments have different success metrics. So we need to be able to compute on the fly lots of metrics that are kind of the same, but with lots of different, I would say, filtering logic. Like you can have the conversion rate, there will always be the same calculation, but the way you filter the data, depending on the experiment, will be very different. Then we needed to support multiple models. Like by this, I mean, originally we were supporting only one data model, so it was very restricted in terms of scope. Now we developed the semantic layer so that we can build many models and define the metrics for all these models, much more flexible. We need efficient filtering. For industries, it's very specific, but we have 3 layers of filtering. We have filterings at the event. We have filtering per visitors on the website, per every action that they do, and then we have filtering at the session level. And so all of these granularities have different logic that we need to handle, and it needs to be placed in the correct place. And then we need to handle different analytics workload. On the reporting, we do a lot of different kind of reports. We have cumulative analytics, we have segment analysis, we have funnels. All of this makes lots of query patterns that we all need to handle into one semantic layer. So how did we build it? It's not very complicated. It's 3 main things. So first we have the protocol buffer. It's something that we use heavily at ABTST, so it acts as a contract to standardize a bit the communications between our tools. Then we have the query builder, so it's the core engine that's going to translate the metrics, the dimensions into the complex SQL queries. And then we have the data modeling. So data modeling part, think of it as a big dictionary where you put all the definitions for each and every dimensions, metrics. So how does it work for us? So our query builder actually it's a Go library. And to integrate with other applications, we package it as a shared library so that we can use it in Java, in Go, other languages. And so if I take the example of the reporting API, so it's one of the main API that powers the reports. When the end user is going to send a request with dimensions and some metrics, on the application layer, on the API, it's going to translate this like small JSON into a protobuf message and send this protobuf message to the shared library. It's going to get the result like the complex SQL strings, then execute on the data warehouse, and then we get the results. So it's very convenient, it's very portable. That was an important criteria for us. We've done integration with Java, with Go, even an MCP server in Python. It also integrates very easily. Now, how do we build queries? So this is the big picture of how the query builder works. So you see at the entry point you have the Protobuf message. From there we're gonna look at the table that is defined in the message and assess which data model we need to use. And then the next step is gonna be the view builders. So the view builder is gonna check the metric and also the model that is to be used. And from there it will decide to create one or many views. So I'm gonna go over this in details in the next slides. And last step, you have the assembler. The assembler will take all the views and format them into the final SQL. So how do we define the request? Nothing really fancy. So we have a Protobuf definition on the right, where you can see dimension, metrics, filter, order by. Here on the left is an example of how it looks like for some requests. So you can see that on the metrics we can define filters. And one thing that is very convenient is this abstraction over the filters that we call the filter container. We have multiple types. We can have a composite filter, which means the filter has many filters inside it. Then we can have a single filter, so it's the simplest we can do. And then we have other specific type of filters like URL filters to do some regex operations. So with that, we're able to modelize unlimited possibilities in terms of filtering and very complex queries. Next, let's move a bit to data modeling. It's very simple. We actually have two core components, so the metrics, what we want to measure, the dimensions, how we slice the data. We don't actually have anything with relationships yet. Some tools have it, I know. But we wanted to keep it simple by just one data model will just target one source table in our data warehouse. It's much easier this way. So here's an example for dimension definitions. So you can see we have the dependent that's going to link to a field in the source table. Then we have the expressions. We could be the field in the source table, but we can do some transformation on it. And for all the time-related dimension and metrics, we adjust to the time zone of the client at query time. And we have across all the data models, we have more than 300 dimensions defined, so it's a lot. Next, the metric definitions. So a bit the same. We have the dependent, we have the expressions, we have the definitions of the metric. One thing you will notice, we have expression with filters. So we use this to specify exactly where we should put the generated filter for a metric. And with this, we use this to generate the dynamic goal. And I've checked on the database recently, across all the experiments that our client runs, we have more than 700,000 custom metrics. And the fact in our data model, in our definitions, we have like hundreds of metrics. So it's much more manageable to have 100 metrics than look at the 700,000 custom metrics of our client. So we've seen, how we send a request to this query builder, how we define the data model. So now how do we build queries? So we have the view builders. The view builders actually is gonna disassemble a complex query into several logical parts, and then it's gonna orchestrate them a bit like a DAG. And so think of a view a bit like a common table expression. In fact, this is what it builds. It makes many common table expressions in SQL, and then it orchestrates them in the right order. So you can have an example with a primary view that selects the required field for the report, that applies the first filters on the populations. Then a filter view that's gonna just select the visitors that match the segment A. Then all of this is gonna go to aggregate views that's gonna aggregate, for example, the conversion rate, the number of unique visitors, and some others. And then we're gonna have the select view that's gonna select all the data needed for your report. So it's very modular, very easy to reuse some parts, to test. And our query builder is smart enough to know that in some cases you don't need to build many views. When it's not needed, it's just a simple select, and you get all the results that you need. So in previous slide there was a mention about filter view. Why not simply do all the filtering in aware conditions? So this is where we add lots of business knowledge. Let's say we want the number of page view for a visitor having interest in lawnmowers. In that case, I could simply put aware clause on, okay, the visitor have the segment interest in lawnmowers. It will get the last 3 hits, but you know that the first hit is actually a page view as well, so it needs to be counted. So that's where we have this concept of filter view, where we're gonna gather the list of visitors that match this segment at least once, and then we're gonna reuse this result into other cities in order to preserve the full activity of users, and then correctly compute the metrics. A more complicated example, multi-stage calculations. So this feature is about computing a metric depending on another metric. So here the example is about the cumulative number of unique visitors. And from that we want to derive the daily new visitors. So you could have in the aggregate view, we're gonna compute the cumulative number of visitors for the current months. And in the delta view, we're gonna reuse this metric to derive the daily new visitors, because you know that the daily new visitors is gonna be the difference with the previous day of the unique visitors. So it's a very powerful feature, allows us to do nice things in the reporting. The last part, so I talked about the view builders. If you remember, after that there was the assembler. The assembler is very simple. It's gonna take all the views and then it's gonna format them into a correct SQL queries. So it's like putting the name of the cities, putting the commas in the right place, doing the last select. It's very simple part actually. So I've talked about how we build the queries, how we define the request for this semantic layer. Now I want to talk a bit how we build features on this. So every time we have a data guy that wants to add a feature, it commits onto GitLab. From there we have the CI running. So the CI, if it succeeds, it will compile into a shared library, put this into GCS. It will also automatically update the documentation of all the data models into Confluence. So we have the full documentation of every metric, every definition of every dimensions. So it's all automated, synchronized with Git. So yeah, it's really less confusions for all people using analytics. And if it fails, we have HTML reports. So let me talk a bit about this HTML report. So in our HTML reports, we have hundreds of scenarios that represent a real production workload that we have. So we specify many scenarios with the expected SQL. So in our test suite, we're gonna generate the SQL. We're gonna compare the generated versus expected. Then we're gonna validate the execution on ClickHouse. For this, we use test containers, and we get the results in the HTML report. So here's an example. So if you see that the execution passed on ClickHouse, so this query is actually correct. It's executable on ClickHouse, but it was not what we expected when we compare with the expected query. And so it highlights precisely on which line there was a difference. So it's very convenient for us engineers. Every time we make a change, we can directly visually see which part changed in our query. So that's it. So today, this semantic layer for us, it's really a huge benefit in terms of efficiency, because we have uniform metrics and dimensions that is used by many services. We just define them once and it's usable everywhere. It's for the velocity of our team, because we have a good CI and a good visual testing that allow us to ship fast. And then with all the scenarios that we test also, we really have good trust into our analytics and the value that we provide to our clients on the reporting. So thank you, everyone. If you want to build a semantic layer or make a new open source project, I'll be happy to share some stuff with you. And question?